Right, so welcome everyone to our weekly call. Hope you've all had a great week. As you can see, the theme of our call this week is on sort of the deployment and scaling of encrypted DNS resolvers. And in fact, if I just move on a slide, specifically a panel discussion on the learnings from the deployment and scaling of encrypted DNS resolvers. So we'll kick off in a moment with an extremely experienced panel of Crowe from Comcast, Puneet Sood from Google, Otto Moerbeek from Open-Xchange, bless you, Paul Adair from Infoblox, and Ralf Weber from Akamai. Just to sort of look at, well, Joe and Puneet first sort of talk about some of the learnings from actually operating support, well, operating resolvers and scaling out support for encrypted DNS. And then Otto, Paul, and Ralf can add some insights from the perspective of the software development as well, which I think will make for an interesting, hopefully, exchange. I'll keep an eye on the time, and if time permits, we will open up for sort of questions from others, but we'll start just with a few reflections from each person before doing that. And then if we have time when we finished all of that, then I'll pick on a few other things as well. But the main point of the discussion this week will be on the panel. Now, shortly before we kicked off, Joe messaged me to say he might be joining slightly late, so I can't see him in the list at the moment. So yeah, I was going to start by asking sort of Joe to give a few comments, but I might instead, if it's all right, Puneet, maybe start with you, and then hopefully Joe will join us, and we can hand over seamlessly from you to him and continue. If he still hasn't joined us, then we'll carry on with Otto, Ralf, and Paul, and sort of Joe will kick in at the end. So depending on when. Oh, in fact, and there he is. Fantastic timing, Joe. I was about to ask Puneet to kick off, but as you're there, and I'd sort of build it as you're going first, are you all right to kick off first? Or
I'm okay. That's, you know, I was just doing a DNS change and making sure everything didn't blow up. So I know how a lot of people here like to do those things early. So yeah, Joe Crowe from Comcast. I know that a lot of us have talked quite a few times in the past. Work for Comcast, principal engineer. Here to share a little bit about high level about what we're doing within our encrypted DNS platform. I always like to share these numbers. We are currently about 1.4 trillion queries a day for our regular DNS. So go over 53. And for DNS over HTTPS, we are sitting around close to 900. Sorry, I had a chart right here. 900 billion now. So we're getting nice and big traffic for encrypted DNS. We haven't ran into many issues as far as customer reported issues with our current platform. It's kind of ran pretty smooth. We are doing some tweaks with our vendor to make sure we can get more performant metrics and performance for the customer. As I've mentioned in the past, is, you know, one of the big things that we've always ran into was not having the correct tooling to make sure that you're getting the best out of your platform. Some of that has changed in the past, and it is sorry, guys, are jokes. Some of the tooling has changed, so Dig and KDig, and we're able to use HTTPS with that, and that's a big help, especially when you're trying to do loops and make sure what's you're doing what you need to do. We are currently trying to look more into the reconnection, reuse of connections. And we are also moving forward with trying to use native vendor support. You know, Akamai and Bind, they have, you know, and Unbound, everybody pretty much has DO available and DOT available. So we're now putting some focus onto that. We want to make sure that we get the best bang for our buck. You know, the current infrastructure is working as is, but it's, you know, we want to make sure that we can't, you know, we're not spending all this money for something that could be, you know, what we already have available to us. So we're working on our next gen architecture on that currently, and we are just trying to get any input from anybody that's doing the same thing, and try to keep that communication up with everybody here, or anybody that's interested about encrypted DNS. Our DOT encrypted DNS part of it, we're not seeing much on that. That's, you know, that's more reliant on like Android and the OS. And since we do not currently have any triggering mechanism for switching either DOT or DOH, it's, you know, we're not going to see that big jump there currently. We are relying on kind of the Mozilla and the Google context switch within their client software. So I know that Microsoft is coming out with doing DOH on their back end, and they're trying to come out with the best ways to do the auto discovery. You know, while we go forward with that, we're going to continue those communications with those vendors, Microsoft, Apple, Mozilla, Google, make sure that we get the best out of what we can offer for those clients. And that's what I have for the most part. That's kind of high level. I can't go into too many details, but if anybody's got any questions, comments, we still have the open doh.xfinity.com, so anybody can use it. It's not as performant as what you would get on our customer network for Xfinity, but you can. I do highly encourage anybody and everybody, especially within this group of people. I would love to see what you guys can see or can kind of beat up on that open end of it, so we can kind of take those learnings back and make it a little bit better for everybody.
Andrew, do you mind if I ask Joe a question?
Yeah, sure. Jump in, Paul.
Joe, I would just have one question on your planning for future platforms. How does acceleration for encryption figure into your plans for hardware or, you know, public cloud platforms for your DNS?
So the acceleration part of it, we are really, it's now acceleration for the SSL or acceleration of just encrypted DNS becoming more.
Yeah, for the SSL and TLS itself, right? I would say that more so, but I would ask both, just out of curiosity.
So acceleration is a big proponent of why we went with a box in front of everything right now. We wanted to make sure that we had a separate appliance kind of doing that TLS acceleration and decryption without trying to bog down our servers. Our future architecture is going to probably be maybe a mix of that. We have to get more testing done on doing it natively and on our servers, but that would include making sure we have enough RAM and CPUs for that bare metal to kind of do that. It's kind of hard to containerize this right now, especially at our scale. So it's not off the table, but it is something that, you know, we are trying to find out the best way we can make that acceleration kind of a microservice.
I can see a couple of hands raised. So let's go for those. Peter, then Zaid, if you want to come in. So Peter first.
Thanks. I think this is a question for you and everybody else who will be talking as well, but what's the roadmap for DOQ? And it was asked in the chat as well by Libor, I think. So
you know, I think a few of us were at DNSOARC and noticed that when Google was presented with this question about when their roadmap was DOQ, they kind of said, well, we don't know yet. And these guys, they're the ones who have have been pushing it out, making it the thing for HTTP3. And so we're kind of at that part now where how much effort do we put into it if Google's not putting into it right now? It's on top of mind, but there are other things that are currently going on with DOH and the discovery and trying to get this to become more of a better standard than it already is, and to build on what's already there. At least in the thought process of where I come from, I'm not speaking for Comcast as a whole. If Google is kind of saying, hey, we're putting a pause, we're not going to implement it right away when there's a lot of other people implementing it, it kind of puts a pause on our team to be like, well, how much effort do we need to put onto this? Whereas though where DOH was kind of thrust upon the whole DNS eco structure, here we go, you got to do it, you got to understand it. We're not being, it's thrust upon on it with DOQ currently.
Thank you.
Okay. Zaid, do you want to come in?
Yeah, thanks, Paul. Can you shed a light on the performance stacks with your TLS accelerators relative to DO53? Thanks.
So our acceleration stacks are compared to DO53. I mean, DO53 is just performant. We are seeing pretty good DNS round trip times for the DNS over HTTPS. It's not as performant. It's not going to be as performant. I think that's a known thing amongst a lot of us because there are more moving parts at that point. Our accelerators that we have in front are doing pretty well, but given that they're not in every data center that we currently have our DO53, it's not, you're definitely going to see that hit there. But I think if we move it closer to each customer, those accelerators will do a lot better at this point. And even if we can get to DOQ and get that at a point, I really am interested in seeing how that helps the acceleration, because TCP is kind of taking a hit on the, especially when you start getting bigger and bigger in the numbers and the connections per second. How often do those connections get used? How often do they stale out? Those are the things that we really are now trying to keep an eye on and be better with, because DO53, you don't have to worry about that type of stuff at all.
Thank you, Joe.
You're welcome.
Great, thanks for those immediate questions. I'm not going to call out the questions on the chat just yet, because I think it might be helpful perhaps to sort of hand over seamlessly to Puneet to get sort of his take from Google's perspective, and then that might sort of address some of the questions in the chat and also start to broaden out the conversation a little. So if that's okay, could we sort of seamlessly hand over to Puneet to just give an update from the sort of Google's resolvers perspective, if that's all right?
Sure. And so I see Joe punted over the DOQ question to us, but I'll address a little bit of that towards the end. So I didn't prepare any slides, so I'll just summarize things off the top of my head, and feel free to ask questions. I think that will probably be better. So during 2019 is when Google announced support for the standardized versions of DOH and DOT. And since then, traffic has grown from something like 2.5% is DOH and DOT to over 12% late 2021. I think it's gone up a little bit more since then. It's almost 9 months since December when I did that detailed measurement. The one other thing to note there is that Chrome, Android in the latest version of Android has switched from DOT by default to DOH if it's available. So we are seeing that in our metrics as Android 13, I think, is rolling out, that DOH has overtaken TLS as the primary encrypted transport. Other than that, I think the rollout for us generally has been smooth. We haven't hit any problems. part of it has to do with the fact that we are able to reuse Google's existing HTTP implementation, the Google web front end, which is able to terminate DOH and DOT queries and then forward the DNS requests to the actual DNS resolvers. So we benefit from that, no problems as such. The one thing definitely is that DOH and DOT are less performant. We get probably about a fifth of the QPS we can get on DO53 UDP with what we can get with DOH. The other thing there is that given that you need certificates to terminate DOT and DOH, it does constrain us somewhat in where we can deploy it on Google's compute footprint. That's something which does constrain things for us, but not significantly. Other than that, in terms of DOQ, this is the downside of integrating with other systems. We have to wait for all our dependencies to line up. We would love to do DOQ, but given priorities and making sure everything lines up end to end, it's a complex system internally. So once we have some of the dependencies lined up on the resolver side, it's a relatively straightforward thing for us to do. So no ETA, but we are looking into it. Other than that, I think I don't really have much else to say, so I'm happy to take any questions.
Okay, let's pause there for a moment. People follow Zaid's lead and use the Zoom tool to raise your virtual hand if you've got a question. And Zaid, do you want to jump in?
Okay, thanks. Yeah, just a quick question on any analysis done in terms of DOS or DDoS. If you've seen any kind of patterns or anything of that nature so far? Thank you.
Are you saying specifically with respect to encrypted transports?
Yes.
So I think there's really two answers. One is that we haven't really seen any significant problem there. And partly the fact that we are able to leverage Google's web front-end stuff, a bunch of the standard web DOS protection comes into play. But as far as I'm aware, we haven't seen any DOH or DOT attacks as such. There may be the standard TCP related things or web related things, but nothing of significance. The attacks we really see are over UDP. And in that sense, I think DOT, DOH are better because the random, simple, cheap attacks, you hijack some machines and start sending UDP queries. That's not possible over the encrypted transports.
Okay, thanks, Zaid. Puneet, just to clarify, I think you said as you're seeing DO and DOT less performant than regular DO53 because of the certificates, etc. Did I get that right? Just to make sure I didn't misunderstand.
So certificates more constrains the edge footprint where we can deploy because we can only deploy it where we have the certs we can trust.
Yeah.
So that's that aspect. In terms of the performance, yes, definitely we can do less QPS over these protocols.
Is that a function of compute power that's needed with the encrypted protocols?
Yeah, and UDP is very cheap, right? You get one packet if you can read it well off the wire and answer from the cache. That's very, very cheap, right?
Yeah, fair enough. And then maybe I'll throw a question at both you and also Joe, just picking up from the chat. There's a mention of support for DDR or indeed DNR for that matter, which I know some recursive resolvers are already supporting support sort of pre-standard for. Do either of you have any plans to support either of those discovery protocols that you're able to comment on?
I can go first. I forgot to mention, but we have supported DDR now for, I think, either early this year or late last year. DNR, I think that's more DHCP related, so that doesn't apply to us, maybe to Comcast. And was there any other question there, Andrew?
No, it was specifically on just supporting those two, I think, at the moment. Joe?
Yeah, we've been doing some testing on the back end with that, and just trying to see what we can do on our end. But it's something that for DDR, we're trying to push forward. It's just a matter of making sure we get the right testing involved. Trying to push something like that out there, and then inadvertently turning up DOH everywhere for everybody. We don't want to do that, unfortunately. We'd love to, but going back to the compute power and things like that Puneet touches on, it's the same concerns that we have.
Yeah, fair enough. And I'll also read out loud your correction on numbers, just to make sure people don't go away with the wrong impression if they just get the audio, which is DOE queries is running at 90 billion a day. I think that is unit wide.
Yeah, it's 90 billion a day.
Not 900 billion.
Yeah, I was looking and I didn't catch the decimal point there. So.
Yeah. I was quite impressed at the percentage of traffic when you first said that. It's still impressive, but
yeah, but I'm like, oh wait, that math doesn't check out.
Fine. So people note that it's 90 billion, which is still a big number, but slightly less big than 900 billion. Brilliant. Okay, well, just I think Puneet, you'd covered your main points. There will be some more things, sort of questions on that, which you can pick up from the chat. But let me move on to our three software vendors first, and then we can broaden out the discussion. So I think I suggested that we would then sort of next go with Otto. So bear with me whilst I juggle my screens so that we can share the right slides, which is always harder on a very small laptop screen. But I think I've got this. So you should now be able to see Otto's slide.
Yeah, that looks great.
Fantastic. So Otto, just tell me when to move on.
Yeah, I think we can move on. So my name is Otto Moerbeek. I'm working mostly on the recursor within Open-Xchange, but I'll try to tell something about DNS dist as well, especially in relation to encrypted DNS. Of course, encrypted DNS has an abundance of protocols, and we mainly try to tackle that complexity of the different protocols by separating the protocol processing from the actual resolving processes. So DNS dist does the communication part, load balancing part, maybe some policy decisions, routing to various backend servers, and that's mainly to reduce complexity. And what we think is that the various protocols that are available, of course, increase complexity, but luckily DNS dist was designed to as a protocol engine, more or less. So you can run the DNS dist on hardware which has acceleration. We'll talk a bit later about that in more detail, in a bit more detail, and run precursors on hardware, which is mostly suited for those purposes. We are a software vendor mostly. We do have professional services, but we do not run our own resolver service of any kind, except for testing purposes, etc. So, but we have a few customers and also other users, because we are open source. We also have, of course, users which aren't our customers that run large sites. And well, what we get from feedback is that a combination of DNS dist and recursor PowerDNS recursor or potentially other recursors, of course, because DNS dist is not vendor specific with its backend, works quite well. There is maybe a difference in that our software is also run on a very big variety of hardware, from really small embedded machines. People run DNS dist with that, and to also very big clusters, farms of resolvers. And what we see on the other side, let's say the client side, is that the encrypted DNS can be really hard on those CPUs. A CPE, typically CPE, a low-end CPE, could use several milliseconds or tens or maybe hundreds of milliseconds to do even a TLS handshake. And of course, even if you have on the other side, on the server side, a big hardware with all kind of hardware acceleration, that's not going to help that CPE directly. So there's a big hurdle there as well. We're not only concerned about handling the load on the server side, but the client side is certainly something to look into, to keep in mind, for us at least. Phones and tablets and things are quite fine because they have relatively powerful processors, but the small embedded systems, the CPEs, are not as powerful. And what we see from our customers or potential customers, that they really are interested in offering encrypted DNS, and they use it actually as well. And so the ISPs and other parties are really keen on it. And well, maybe I have no hard data. We're moving to a point where encrypted DNS, well, be at some point in time, maybe will be as normal as HTTPS is now. It's almost, we are almost in a state where a regular unencrypted HTTP connection is considered, well, that is strange. Why isn't that HTTPS? And at some point, probably DNS will go into that same direction. So to give a quick and small overview of the various pieces of software we have and their features with respect to encryption, is DNS dist has had DOT and DOH support for quite some time. But what is important to note is that recently the protocol handling was much improved, starting with out-of-order processing for incoming DOT. That allows, of course, clients to be quite efficient doing multiple queries over a DOT connection, and it also saves on handshakes, because a connection can be reused even by multiple programs on a single computer, and sharing the DOT connection without having to wait for each other. More recently, we introduced outgoing DOT and DOH for DNS dist, and also together with that, almost complete cross-protocol processing, that which before that we could of course do something in that area, but it's now very versatile. You can map incoming DOT to UDP backend, or to a DOH, whatever you like there. And so that adds a lot of versatility, and since we expect more encryption protocols like DOQ to come up, and maybe even more after that, it's very important that you are not constrained in that respect. So the load balancing really works well. DNS dist 1.8 will introduce auto-obfuscate for DOT and DOH. So using the Ddr hints you can find in the DNS itself. So that is nice. especially because it doesn't require any configuration except for enabling the actual feature from the system administrators. So better also, we have much better support for different form of hardware or kernel based optimization, isolation of TLS. Then on the roadmap, we have DOQ. That's also, I think our estimate is that it is very interesting, but there are for some reasons not moving as fast as you would like to, maybe. There seems to be some hesitance going on here and there. And oblivious DNS, and there's a question mark there. That does not mean that we don't think it's valuable, but we have some discussions on the actual architecture. So, of course, DNS dist is mainly a load balancer. But so the question remains which part of the oblivious DNS processing will end up in DNS dist and which parts will be done by other software. So that's maybe we are discussing the architecture, and it's on the roadmap. We think it is valuable. Some customers are really interested in it, and we like to do it. So, and then on the recursor side, that's the next slide. There is, of course, especially since we have the architecture where most of at least the incoming encryption processing is done by DNS dist, recursor itself mainly concentrates there on the outgoing DOT to specific authoritative servers or potentially forwarding targets. Last year we implemented outgoing DOT, which was a manual configuration step. So we could select it for a specific forwarder, forwarding target, or manually listed authoritative servers. But the last release a few months back introduced the unilateral dot probing feature. So you can instruct the recursor to discover if a authoritative server does support DOT. That is an experimental feature, but what we are seeing now is that only a few of the big resolvers do support DOT. Our customers who have been experimenting with this report, for example, that most of the Facebook-related DNS authoritative servers do support DOT, and if you instruct the recursor, it will you start using DOT to those authoritative server. And recursor 4.8, which will be released in I think in 2 months or so, will have some tweaks to that process, especially on the reporting side, because it's very interesting to have good reports on which authoritative servers do support DOT. And we also do padding of the outgoing request, which is a nice feature to make it more private what's going on to the authoritative server. And here's also the oblivious DNS with a question mark mentioned because we are still in the process of discussing the architecture, and also that the recursor should play a role in this, but the exact role, the exact division of labor between recursor and DNS dist is still something up for discussion internally here. So that is from our software point of view, the main things we have been working on, and if there are any questions about it, I'd like to answer them.
Okay, so if anyone wants to put their virtual hand up, feel free to do so now, or if you want to sort of hold off and then ask questions at the end, that's fine as well. Okay, I'm not seeing any hands raised at the moment, so let's sort of press on, and then we'll maybe come back with any questions at the end, if that's all right then, Otto, but thank you.
Yeah, okay, that's fine. Yeah.
Right, let's see if Paul Adair from Infoblox is calling in from an airport somewhere in Texas, so fingers crossed his connection holds up. But
Hey, Andrew, am I coming across okay?
yeah, you're loud and clear at the moment. So fire away, Paul.
Excellent. All right, so I'll talk a little bit about Infoblox. Similar to Otto, we have seen, a good bit of time, from our products put into encrypted DNS. So our initial, investigations in there were in our cloud service we launched, based on DNS crypt, I think in about early 2017, if I remember correctly. We've been evolving the product. Our on-prem product we launched a couple years ago with our 8.5.2 release. We implemented Dot and Do, and we've since updated our cloud products. Adoption rates have not been very high amongst customers so far. I think a lot of that is driven around, the clients themselves, right? Most of the clients don't have a good way to discover. From a scalability standpoint, the studies we've done seem to show that, a small amount of acceleration will take care of most enterprise customers. So if we, most of us here are service provider focused, right? But, Infoblox sells into both markets. And so what I would say, we have learned is there's enough scalability to fit most enterprise use cases in your typical Intel platform virtual machines that most folks are running today. And so there's, our experience there has been generally positive in the enterprise space. In the service provider space, the problems that have been echoed by the teams here, we've run into as well. Just the amount of CPU it takes to, to reliably build encrypted DNS is remarkable, is orders of magnitude greater than it was for unencrypted DNS. And so it's very expensive. What I'm seeing is a lot of customers are waiting on that. And in a lot of the space, what we're seeing is, with the migration to CNF that is being driven a lot by 5G in most cases, they're starting to finally plan for, some type of encryption acceleration on the hardware platform. I've seen a decent amount of NVIDIA show up there as the primary sidecar that's going to be, or the primary thing that's powering the encryption sidecars in those Kubernetes platforms. And so that's my expectation when we'll kind of catch up there is when the service providers actually finally have those CNF services in production and ready for service. Most of the service providers out there that I've spoken to aren't there yet. They don't have a lot of they aren't very far into their containerized projects. So most of them don't have, many production services operating on CNF. It's still a vast majority of virtualization or, physical acceleration for those cases like, Joe had spoken of at the beginning for encrypted DNS, where you pretty much just have to use a hardware box if you want to go and do it today. From the standpoint of enabling like the DNR and DDR services, the DDR service, anyone with a typical DNS engine, authoritative DNS engine, it's relatively simple to implement that. So, for my products, we have unknown record support, and you can go and enable those records. Even a couple of years ago, you could do that before they existed. But the adoption there yet again. Until the clients have them turned on by default. I kind of noticed some conversation with, I think, Tommy Jensen earlier that their implementation is not going to be on by default until, either the clients have the clients have a way to turn them on manually or turn them on automatically in the service provider space until it's on by default. The adoption rate of encrypted DNS is going to remain exceptionally low, right? And so, we're trying to help customers plan for those situations. And right now, the big planning part of that and helping with them is helping them understand that they need to plan for encryption acceleration in their DNS platforms in the future. So hopefully that's not too much rambling, but
no, that's helpful, Paul, and you cover quite a lot of ground there quite quickly, which is impressive, given your connection. Let me just see if that prompts any immediate questions from anyone. I see John Todd has raised his hand, so John, do you want to sort of jump on?
Yeah, thanks. Since your primary customer base is enterprise, I'm interested in hearing if there's been any significant resistance by enterprise customers to allowing encrypted DNS to servers outside their administrative control domains. And if so, is that by use of canary domains or is it by use of just outright blocking?
So absolutely, when I inform customers of that, it's very common for them to say, "Oh yes, we absolutely have to be blocking that," if they weren't already looking into blocking that. So I created, I have an automated filter that I give them that I sell to them that they can implement on their firewalls or their DNS services and other places to to block resolution or block even connection to the known public resolvers. When I'm consulting with an enterprise customer, I'll generally encourage them not to send a DNS queries to someone that they don't have a business relationship with, right? I mean, that's not a good thing to do. You should be in control. Our oldest advice has always to be, remain in control of your DNS services, to only allow, internal users to access DNS servers that are owned or operated, or at least, you have some form of business relationship, and to block all others. And so, my focus in that space initially was to, help automate that blocking process and, give the customers a way to keep their enterprises safe.
Okay, so you're doing it just by firewalling and not necessarily through canary, or are you using both?
Both. We offer, so our cloud service itself, blocks the canaries, and we also offer, even for like on-prem only users, we have a list of domain, the canary domains are in the block list as well.
Okay.
So we block by IP address and by DNS name, depending on the technology that needs the blocking.
Great, thanks, John. I think Peter, Peter, you had your hand raised. Did you want to come in?
Yeah, sorry. Thank you for that. That was brilliant. I was wondering if you've got any stats to share, like some numbers about comparisons between encrypted and unencrypted traffic.
Yeah, unfortunately, I don't. My cloud service is exclusively or almost exclusively encrypted traffic. So we do allow a small amount of unencrypted traffic into our cloud service, but it's only if you basically told us exactly what IP address it's coming from. Most of our traffic comes through either a proxy or a client installed into the operating system itself for our cloud services. So I would tell you like 99% of our traffic is encrypted at this point, but it's not comparable to a public service or even a service provider service.
Cool, thanks.
Okay, thanks, Peter. Right, no other hands raised, so let's seamlessly move on to Ralf, and then we've got some more general questions I can sort of offer up to people. So, so last but not least, Ralf is from Akamai, who people will know well in the DNS space. So, Ralf, do you want to come on and just give a quick update?
Yeah, I don't have slides. I mean, Akamai is sort of both in the kind of business of providing DNS software for ISPs to run it, but we're also having managed business where we kind of terminate DNS, dot, or what have you. So overall, I've been doing DNS since '94. It's probably 28 years. And initially, I mean, DNS, it was a 50 byte or 45 byte question, and then a 50 to 60 byte response, and that was it. And you can make that very efficient on even kind of Medicore hardware. And so DNS was very scalable. You could put a lot of stuff on one machine. Now, when you come into the encrypted DNS space, I mean, there's a lot of stuff to keep track of, because DNS being UDP, state was not the thing to do. However, the current DNS encrypted protocols, both DOT and DOH, require TCP, which requires state. And then you need to keep kind of track of the keys and the tickets that you have in the SSL space. So it is a lot of kind of stuff on top of what you have. So what Puneet said is you cannot expect to get the same performance out of DOH or DOT than you can expect of regular DNS. So we have taken a different approach. We have kind of integrated the stuff into our resolver. So because, I mean, DOT, DOH, and later probably DOQ are the biggest changes to DNS in probably over 20 years. And they're very, I mean, they require very different architectural responses because you cannot expect to have a same server kind of handle the same amount of clients as you did before. So you probably want to scale it out a bit. On the same stuff, you also in the future require to call out using DOT, DOH, and DOQ. So something that is kind of like was an initial DNS architecture I would hope was coming back, and that is DNS rather than moving into a central place, and 5G also has one trigger there, moving out to the kind of as much to the edge as possible, because one of the things that especially with these encrypted protocols, it's not just one packet. I mean, if you do a full handshake, it's three packets before we actually get an answer. And all of these are round trips. So you have to get the packet to the server, back from the server, back and forth, back and forth. And this, the smaller the latency, the faster is the response. Granted, once the kind of initial connection is set up, it's getting much better. But I think that future architecture in these kind of have to think about putting DNS as far to the edge as possible. And today actually is, I'm not sure if people are aware of that. Today is the day when people can firstly, or resolver operators can firstly decide if they want to take a big portion of the traffic encrypted or not, because people might be aware that Apple is releasing iOS 16 today, and iOS 16 has the DDR upgrade mechanism turned on by default. So if you run a resolver and put the regular DDR record there, and again, we support all of that. We had DDR support for a long time, and then you can actually get your user to use encrypted DNS with either dot or DO. It's sort of your choice because the DDR record that you put in there decides where to go. And I agree that at one point, we'll probably think of kind of the days when there was a decision if kind of DNS traffic was encrypted or unencrypted. Those days will kind of pass. I'm not sure when, but there will be huge portions of traffic, DNS traffic, going encrypted in the next couple of years, and kind of people need to prepare for that. So that's all I had, and I'm open to questions now.
Fantastic, thanks, Ralf. So anyone got any specific questions for Ralf before I then open up to more general questions?
Maybe
go ahead,
maybe
Mark.
not questions. No problem. Maybe not questions for Ralf, because I should know most of what Ralf is thinking. But I did want to maybe just share some higher level points that we're seeing, at least around initial operator adoption. So we have a lot of operators who are playing with DOT and DOH, and they have been for several years now. We are seeing kind of a general number of 5 to 10% encrypted versus unencrypted. A lot of that is very, very dependent on whether or not that operator works with the browser vendors or clients to get in the various provider lists. We are also, I think, having the same conversations that Paul had hinted to, where many of our operators are in some form of change when it comes to their infrastructure. A lot of them are still bare metal because they have massive volumes of queries per second to deal with. Many of them have been in some form of virtualization journey, and several are looking at some form of containerization. It's going to be some vendor flavor of Kubernetes. And across most of these infrastructures, there is always going to be some constraint in terms of the compute resources that they can provide to the DNS server. So one of the things that we're looking at is, as you move away from bare metal into VMs and into containers, it does become a little bit more difficult to get guaranteed access to some of the underlying hardware. So one of the things that we've been looking at and playing around with is whether or not to invest in many of the offload technologies. So you have a real big collection of acronyms, your QAT, your XDP, SRIOV, DPDK. There's so many cool technologies out there that you can leverage to accelerate some of these things. However, they create deployment constraints and they have to be available on the infrastructure that you're deploying into. So what we've kind of done at a high level is decided, all right, well, we know that encrypted DNS is very computationally expensive, so let's just throw CPU cores at the problem for now. And that's something that is working now for many of our customers who are deploying, but it is also something that works because we're still seeing kind of that 5 to 10% deployment footprint. And as that scales out, we would either need to continue scaling horizontally in terms of CPU cores that can be allocated to specific functions such as encrypted DNS, and we can kind of slice and dice and allocate threads as needed. But it really does suggest that at some point we're going to probably have to figure out how to be more efficient with the heavier query load, because we see the same as Google, and depending on how you're cooking the numbers, you are going to see maybe 25 to 40% of the performance that you would see with unencrypted DNS. So there's a lot going on there, and we're tracking a lot of this, and we've been working with our operators who are deploying. But I have high hopes that things like DDR and the client-side support moving on and kind of onboarding more of this traffic where it needs to go. And I think it's very important that you can kind of direct your encrypted versus unencrypted DNS to the right place. Maybe you have a smaller farm that deals with highly accelerated technologies that can accelerate your unencrypted DNS, and really just being able to shift these things is critically important. And I'm thankful that the client ecosystem is starting to adopt some of these things, and we're not in the previous space that we used to be in, because it was quite tricky to scale in a generic fashion.
Brilliant, thanks, Mark. And in case anyone wasn't aware, Mark also from Akamai. So I would have been surprised had you had some questions for Ralf. It could have been an interesting discussion if you did, but
I'll leave them for off the call.
Yeah, fantastic, thank you. So from the chat, I mean, there was a question about sort of prefetching as one way to maybe give a performance uplift, and I suppose I'd sort of throw into that whether that causes any privacy concerns. So and this is for any of the five of you. Have you got any thoughts on prefetching or indeed other techniques to help performance-wise, or particularly, I guess, for Puneet and Joe, whether you've been testing any of those techniques for that matter?
I can kind of touch on that. So prefetching is something that we definitely talk about at our scale, and even at Puneet's scale. It's something that you really, it could help make things a lot more performant, but it is when you start coming around to localized responses for local areas, how do you kind of get those prefetches working for, say, Chicago versus Florida? There might be different lookups happening there. So that's the type of work we're looking at now, is how could we automate some of that and get that prefetch list to those resolvers in those areas that would be best for those areas, because whatever's being queried the most in one area isn't going to be queried the most in the other. Of course, you have your top hits: Netflix, Twitter, Google. They'll be pretty much everywhere, but they're already in cache. So it's why prefetch something that's already in cache, that's always going to be there, pretty much no matter what. So those are the things that we look at and try to figure out what's going to be best for us. And where does that live? Does that live on a separate cache on itself, or does it, is it a database that you put, and where does that get queried, and what do those lookups to those things look as well? Most vendors have prefetch already included, but we also want to know the resources that would happen, give on our CPUs and our memory and things like that.
Yeah. Great, thanks. Go on, Puneet, come in.
Joe, can you, before I answer from Google's perspective, Joe, you said most vendors have prefetch implemented. Are you referring to HTTP prefetch, or are you referring to DNS prefetch?
DNS prefetch, HTTP prefetch is definitely a very new for us, and we do talk about it. It's just a matter of where would that live.
Okay.
And just given how our infrastructure is set up, that the prefetch would happen currently, that type of prefetch would have to be on our resolvers, just how we're set up.
Okay. Yeah, for Google, we don't have any specific plans for doing prefetch yet. Part of the reason is meaning we have experimented with early refresh or prefetch earlier independent of DOH, and that hasn't seemed to help in experience. For the case where I think the question is maybe more related to, if you know you were loading a web page, you probably know the names you're going to load. In that kind of scenario, I would think you need more tighter integration with the web server side. And we're not sure whether that extra complexity is worth it, because then you would be tying two complex systems together even more. Yeah. Meaning if there's resolverless DNS, if that gets traction, maybe then there is value in doing this.
Yeah, and you make a good point, Puneet. I know some of you will recall that Kenji Bayo came on from Google maybe 6 months or so ago to talk about the potential use of prefetching within the Chrome browser. So putting it more there than in the resolver. And I guess there are pros and cons with sort of different approaches. Okay, I saw a question in the chat from Killian, I think, which was just really questioning, and it's just slipped by on my screen now, about DDR being on by default in iOS 16. I don't know if anyone from our panel wants to comment on that, your thoughts on that and the implications for that.
As I brought it up, I'll kind of take that.
Yeah.
It is on by default, but if you don't have the special _DNS.resolver operator in your DNS resolver for the initial question, nothing will happen. It will continue to use DO53. But if you want to give your users kind of encrypted DNS, then you can, of course, put the record in and then decide kind of where to put them using DOH or DOT. So it is on, but it needs to be, of course, enabled by the operator of the resolver. And I believe Google has it enabled. I'm not sure on other kind of big public resolver what they do. But I mean, they might. We know that some of our customers have it enabled.
Yeah, I know Quad 9 does, as Quad 9 was involved in the original sort of testing, as I recall.
Yeah.
No doubt others do too. Okay, thanks. Thanks for that clarification, Ralf. But yeah, I guess that just underscores that what the trend is, if there was any doubt. Okay, let me just give the option. Yeah, Paul, do you want to come in?
Yeah, the good news here, right, is the standard's finally here. Someone's finally enabled it. Now, you know, customer or service providers and enterprises actually have the ability to use it, right? They have a way to actually enable it and point their clients toward an encrypted DNS server. Prior to this point, there wasn't a good way, right? You would have to go with like a mobile device manager and go talk to, you know, all your Apple devices to make them use your encrypted DNS resolver. Now you have a way to reliably message something that some number of clients on the internet will actually listen to.
Yeah, good point. So maybe those resolver operators that were hesitant making the investment, this will sort of give the nudge to do so, as there will be traffic that will land, albeit with some implications on resourcing. Okay, I'm conscious of the time. I have let the conversation run over slightly because there was lots of good content. If anyone has one last burning question, I'll give you the opportunity to ask that now, but you'll need to be real quick. to come straight in if you do. I'm not seeing any hands raised or anything new in the chat. In which case, let's sort of finish the panel discussion there and say thank you very much. I really appreciate all of you. So Joe, Puneet, Otto, Paul, and Ralf for making the time to come on. Well, judging from the number of people on the call, and I know that was of interest. And I think the last time we did this discussion, I think it was replayed roughly 150 or so times. So I think there'll be a lot of people picking this up post-call as well. So lots of useful information there. I will just very quickly, without taking too much more time, just signpost a couple of extra things just to wrap up. So just bear with me whilst I do this, and this will be real quick because we are over. Just to highlight that from this side, I'm not going to go through all of this, just highlight that the early bird registration for IETF 115 is open, and it cuts off on the 19th September. So do bear in mind, if you want to register, it's $700 through till 19th September, then I think it jumps up to $850 for in-person, and similar sort of saving for remote access. Also, DNS OARC, the deadline for proposals has been extended to 13th September. So you have till end of tomorrow, I think that's at 23:59 UTC, if you have any proposals to submit. And I haven't put it on the slide, but similarly for RIPE, the DNS working group has sort of reached out today to ask for any proposals for the agenda for the DNS working group session within RIPE. So I'll put a link to that with a call recording should anyone wish to respond to that. But so for DNS OARC and indeed for the RIPE DNS working group, Ivy is welcome on things to present. And then finally, a reminder, as we touched on when we were chatting before the call started, that next week, Vittorio Bertola will be joining us live from ICANN, or live from Kuala Lumpur, not from the ICANN itself. I think it's at 11 PM we discovered when he'll be joining, to just give us his thoughts. He wrote a post on the impact of internet fragmentation and digital sovereignty on the DNS industry. So he's going to just expand his thoughts on that on this call next week. So any of you that have not exhausted yourselves at ICANN, I don't think that will be quite thought-provoking, but more on the policy side rather than the sort of technology side this time round. So with that, we're nearly 10 past the hour, so apologies for running over, but I hope everyone found the discussion useful and some very useful learnings, plus some signposting of some futures that are coming up on the software side. So all very thought-provoking. Have a fantastic week, and see you same time next week. So goodbye all.
Thank you very much.
Thanks.